Hi, my name is Mark Smith. I'm the Senior Product Manager for Fuji Bicycles. I'm here to introduce the new design Super Time Trial TT bike. It's called the D6. The D6 is a revolutionary concept in design philosophy. We created a Delta 6 process, which is basically a 6-stage process for the development of the bike. First, it started with a prototype phase where we sat around the table and talked to specialists in materials, biomechanics, physicists and dynamicists. Also, we got together with our top pro athletes to get their feedback in terms of what they want to see in a super time trial or TT bike. We utilized riders from Toyota United and our top triathlon, Matt Reed, to get their inspiration for what the SuperBike should be. From there, we went to some 2D drawings and 3-dimensional drawings to get the basic concept of what the bike should look like. In doing that, we looked at two key areas, aerodynamics and weight. Fit was also at the forefront of our thinking, so with that, we created 7 size. It's the first time trial triathlete bike that is available in 7 sizes. It's also one of the lightest frames on the market. This frame is based on a 56 top tube. It weighs in at 1,290 grams, painted and decal as you see. It's one of the lightest frames, painted and decal on the market. A couple of key features that we packed into this bike. First, internal cable routing. And when we did the internal cable routing, we wanted to make it very easy for the end user or mechanic to assemble the bike. From tip to tail of every single port is a full PVC housing that runs from tip to tail, so you can just shove the cables right through seamlessly without having to fish the cables out of the system. So it's really intuitive, really simple to assemble. Another thing we did, which is not new to the industry, is we removed the front brake that slows down aerodynamics and drag. We moved it to the back of the fork to improve aerodynamic flow. We also did the same concept with the rear brakes. We created a cavity in this unique package, which is still UCI legal, even though it's a cavity created to hide the brake. It minimizes wind drag, and it also creates a nice unique box to house the rear brakes to keep a lot of the grit and dirt out of the system to give you good braking performance. We never liked the idea of moving the brake to the bottom of the bottom bracket like most companies, because you get a lot of buildup of dirt and grit, and then you slow down the performance on the brake. Aerodynamics from the beginning to the end. Super aero down tube, aero seat tube with minimum chainstay rear triangle area interface with an extended external seat mass. The seat mass runs about 150 millimeters from the top tube all the way up inside the external seat post. The external seat post holds 2 unique features. Independent adjust. It's a system that isolates your fore and aft positioning and also your tilt up and down system. What it is when you undo the compression rings that holds the saddle rails, you can now move your saddle fore and aft position without affecting your tilt position. Some people like it's totally at 0, some people like maybe a 5-degree rise or a 5-degree tilt in the nose. This system totally isolates one movement from the other, so once you have things set, you never have to interfere with one position, only adjust the other. Also, we use this unique 2-bolt compression system in the back that holds the seat post to the seat mass. By spreading the loads between these 2 compression systems, we're able to use very low torque forces to hold the seat post in place. Roughly about 4 Newton meters is needed on both bolts to hold it in place and can support a rider weight of over 225 pounds. From there, we move to the rear triangle with this unique oversized cross section. This was key in some of the research development we did in the aerodynamic lab in terms of airflow. Because of this unique cross section that is usually larger than your normal interface, we created a lot of skin friction. Skin friction is the friction of the wind to the frame itself. There's a layer that is built up from the surface of the frame that acts as a buffer for wind drag. creating this large area in this area, we were able to minimize some of the skin friction and air drag by maximizing the area of the rear seat tube, seat stay, and chain stay interface, and seat tube, top tube, and chain stay interface. When the wheels are spinning, there's a lot of turbulence that gets built up when the wheels are spinning. This area minimizes the effect of some of that turbulence as you ride. And it was proven in the wind tunnel. This bike at 30 miles an hour wind, 30-degree yaw, with the wheels turning, outperformed the top brands in the market. And if we compare it against 5 models in the market based on their 2008 bikes, and from that, our bike, the D6, Fuji's bike, came out to be the top performer.